Okay, welcome back. Um, by the way, because I had to stop the recording there partway through that last bit, I didn't actually know how long I'd been talking for. It turns out the resolution to upload a YouTube Premiere is 15 minutes. So if I talk for like 46 minutes and there's this awkward 14-minute gap, or if I talk for 59 minutes, there's a really even more annoying 1-minute gap. Turns out I can talk for 50 minutes without a timer after all these years. Anyway, um, where were we? So we're talking about CSS. This is, again, it's odd because I know for a fact, like you're eating dinner now or whatever. It's what are we, 6:30 if we're watching, if you're watching this at the premiere. I hope you're enjoying whatever you're having. Anyway, okay. So talked about CSS frameworks. A quick footnote on this as we kind of get to this is in some sense the end of the big web standards. We have HTML for content, CSS for appearance, and we need a third, and it's behavior. And I'm not going to say very much at all about JavaScript now. I'm really going to say very little about it in the course overall. The course is just much more back-end focused because I think that's important, and I frankly like it better. But anyway, at least some very thin basics. Web browsers have a programming language. Well, web browsers can run code. There's a script element for that says, okay, here's some code that I want to be applied to this page. Usually that's meant JavaScript in the past. Web browsers are also possibly supporting WASM assembly, bytecode assembly now. I'm going to stick with the simpler version of the world where JavaScript is the only language that's actually, or the only way browsers support running logic. There are other tools, because there was this such like strict restriction of, oh, there's one language and it's what everybody wants to do. Everybody wants to have stuff run in a browser. Other languages cropped up that basically compiled to JavaScript. Transpile, meaning roughly compile, but at the same level, not to a lower level. So things like Dart, TypeScript, and CoffeeScript. So you can write these languages that maybe you like better. They get turned into JavaScript so the web browser can understand them. Or again, maybe in the modern world into WebAssembly. JavaScript by itself, basically a programming language that lives inside the web browser. So one of the things you can do from JavaScript code is manipulate the page. So in fact, like what you're seeing here, like as I flip slides, there's some JavaScript code that is hooked up to the event of me pressing left or right arrow and changes the content, moves some stuff, does that transition. Another thing that JavaScript can do, again, from within the browser, is go back to the server. So, anytime you see any kind of like live updating chat or things moving around a page or whatever, or sort of updating on the page, all of that is going back to the server and saying, hey, are there any new chat messages that I should display? And then putting them there so the user can see them. And it's a programming language. And like I said, like I feel it feels glib to put that there, but I feel like people forget JavaScript is just a programming language. Like that thing that you learned about a loop or whatever, you can do it in JavaScript. I think quite often people start writing JavaScript and they're so deep in the JavaScript world and using the framework or working within the web browser and just being a JavaScript front-end programmer, they forget that they're programming and that, yeah, you can write a for loop. You can define a variable. Like all of this stuff that you know how to do as a programmer still works. It's in a different context, but JavaScript, you can write a program. So that's my very minimalist JavaScript intro, and for that matter, my minimalist HTML and CSS intros as well. I want to move to the back end because again, I think that's important. So everything so far has been happening in the web browser. Like this thing that I'm looking at right now. That's half of the equation. The other half is the other end. So the web browser here is a client. We need a server to talk to it. So web server being the thing that's going to do that, the way they're going to talk is HTTP. So the protocol that's used, with a little bit of a footnote on that, is to talk between a web browser or other user agent web client thing and a web server is HTTP. And again, really, being on the web is a synonym for you can make an HTTP request and get it. You don't usually think of it that way, but that's really what it means. I like HTTP in that it's simple. Like, I can explain to you the basics of HTTP. You can type it with a keyboard. It's not a really dense binary protocol, which makes it kind of easy to work with. And I'm not talking about HTTP here because I have any deep love for the protocol. It's perfectly good protocol. It does what it needs to do, but you need to know some of the tricks that HTTP can do to be a good web developer. There's no way around it. And I definitely see developers who, or I see the products of developers who obviously just don't know the protocol, don't know what HTTP can do for them, and end up hacking around it and doing something kind of weird and unsatisfying instead. So just as a quick example, like I made this, let's face it, not exciting web page, but that's okay. Doesn't have to be exciting. But this URL, well, what happened? Like, I just copied and pasted this, or I click a link and I go to it. What just happened in between clicking the link or typing the URL and the web browser getting that HTML back that it can actually deal with? So the in the networking sense, the client, if you're making web pages, you think it's a browser. If you like networking, you think of it as the client. If you're an HTTP geek, you think of it as a user agent. So the browser is a user agent, but so is something like if I go to the command line, this curl command is also a user agent. It went off and fetched that web page in the same way a browser did. Like, from the server's perspective, this tool and this tool are doing the exact same job, making requests. So that's why this user agent term, it's again something that behaves like a user, may or may not actually be a person. So it's a TCP connection to the server, like, whatever the server part of the URL. TCP port 80 is the default for web stuff. And a request like this gets sent. And in fact, I can, so the telnet command, it's called what it's called, but what it really does is make a TCP connection. Like, really what I'm asking for here is open up a TCP connection to www.sfp.ca on port 80 and let me start typing like on that connection. I'll send some characters and print out whatever characters come back. So I can make this connection, paste that thing off my slide, and make an HTTP request. Like that was a perfectly legitimate request, and I got a response back. I had to hit enter to sort of create this blank line because it wasn't in my copy and paste, but this is a legitimate HTTP request, and let's talk about it. Again, I don't really it's not that every character is critical here, or at least not every character is critical to understand what's going on, but there's some details that do matter. So that very first line is the request line. It's like the first line is special. All the other ones have the same format. And this is the request method, or just the method. Get is the one I'm using, and it's the one that gets used every time you click a link. And then the path part. So the URL was, where'd it go? This. So I'm making an HTTP connection to this server and requesting this path. So this is the way the server knows what thing on that server I'm requesting, and then the version. HTTP 1.1 is not the current version, but it'll do for this demo. I'll say a little bit more in a sec. Everything else in that request are request headers. So each line had the same format, and it's like field : value. So the host is this, the user agent is this. And And there's a weird, in fact, like I've repeated myself on 2 slides here, right? Like I've said, make a connection to www.sfp.ca, and then in the request, I have told the server what its name is, which is a weird thing to have there. It turns out that host header is required, and it's required because one server, like there could be one computer that's listening on port 80 that's doing a bunch of different websites. So it could be that this server, like whatever IP address I just connected to, is www.sfu.ca. It might also be hosting, some site for a dozen different departments at the university. So it does actually have to be told what the server name is, because there might be several options. All the other headers are optional. Who is this person? What browser is it coming from? That kind of information. And again, what I saw there in that request was, sorry, it's there. Again, probably not Mozilla 5 that I'm using, but it's what I typed and what I sent. So the server has no choice but to believe me. A couple accept headers, I'll come back to those. And I said connection keep alive. So in fact, this connection close didn't happen right away. I said, I would like to keep this connection alive so I can make some more requests. I didn't. Eventually the server did hang up on me. And then, like I said, there was a blank line there that you couldn't see because that's the nature of blank lines. There could have been a request body. There wasn't in my example, so that was the end of it. And then once the request finished, so again, this blank line was the end of the request, and then the response came back from the server. Okay, before we get to the response, that request method, again, it was get in my example, and most are. So most requests that get made are get requests, because every time you click a link, you type a URL, get request. The first place that you probably encounter some other HTTP method being used is on a form submission. So you can say form method equals get, method equals post. If you say method equals get, so if I have like a name field and a cost field, like just 2 inputs on my form, those things get encoded as part of the URL, and the request gets made exactly like that previous example. If and I'm feeling an annoyance that I can't manipulate this. Let me just do that. So again, if so that kind of request would get made if I'm submitting a form with a couple fields in it as a get request. And again, blank line, and it's over. If it's a post request, which again, like in the form, I've asked for method equals post, this is going to look like, so it's going to be a post request, a blank line, and then the form data gets encoded in the message body. So there's a blank line here. What follows is a message body. For a get request, it was empty. So that's how the server knew, oh, okay, I can just send my request, the response right away. The request is over. For a post request, there needs to be a message body there, and there needs to be a content length header with however many characters that is. I don't know, it's 18 or so, like however many bytes there are here. And now that's how the server is going to know the request is over. It's when it's got enough bytes. So there's like practical differences there between the get and post for a form. One is like if there's a query string in the URL, you can see it. It's on the screen. So it's something like a password shouldn't be there. On the other hand, a post request, not everything you need to actually reproduce this thing is in the URL. So there's more, like I can't bookmark this page kind of because the URL isn't enough to reproduce it. There's this other data that isn't part of like a bookmark, or if you copy and paste the URL. There's a semantic difference there that, again, this is something where I think I see sloppy developers get it wrong. GET requests are supposed to be safe, which is like they don't change anything. So I don't know, this page on the course website, this really should be a GET request because I can reload it, nothing changes. It's not like when I loaded this page, I don't know, one of you got dropped from the course, and when I click reload, somebody else gets dropped. There's no side effect there. It's just show me the information, so that's a GET request. If there is a change, which is like writing to the database, kind of something more important than like a log message, then it should be a post request. So if I'm going to click something and it's going to make a change, it's going to have a side effect, I'd better be performing a post request, clicking a button on a form that initiates a post. People get that wrong and people are sloppy about it. Sometimes with effects. So this Google Web Accelerator story is basically, so Google Web Accelerator was a thing, I don't know if it was a plugin for Chrome or whatever it was. It would take this page and it would say, oh, you know what? I bet he's going to click on that link. And it would prefetch that page so that when I clicked on it, it felt like everything was really fast. Or maybe if I move my mouse towards that link, it could load it. It's a GET request. It's safe, so I can prefetch it for the user. Then it will be really, really fast. And that's great if the developer is using GET requests properly. If they have a GET request that has some side effect, and I don't know if this is the story or there's another one I saw where there was just, pages would have a bunch of links that were like delete. So you just href equals whatever with a delete link, and you click the link, it would delete the thing. And Google Web Accelerator, well, it's a GET request, it should be safe, would prefetch them, and everything that user could delete all of a sudden got deleted, even though they didn't take any action. So the usual way to get around this, and by the way, if I'm looking at a page that is a post request and I hit Control R, click reload, the browser will warn. It will say, are you sure you want to do this? Like, are you sure you want to reload this page and order again or drop another student or whatever action it is you're taking? That's kind of a weird bit of usability sometimes. So I'm not sure if these diagrams help people, but the standard sort of workflow would be you fill out the form as a user, click submit. It's a post request because it's a side effect. The developer knows what they're doing. And the user gets back a 200 OK and just like is looking at a page. Well, you look at a page. Sometimes you reload it or you navigate forward and back and you view it again. That causes another post request. The user gets a warning here. Maybe they don't understand that warning, and the action gets taken again. That's not probably what you want as a developer or as a user. The post redirect get pattern is, from the user's point of view, it starts the same. Fill out a form, click submit. It's a post request because there's a side effect. On the server side, you do some stuff. Instead of sending the page back, send a redirect. Okay, now that you've undertaken you've made the order, you've dropped the student, you've done whatever. By the way, I can't drop you from a course. I don't know why I'm using that as an example. But yeah, you've taken the action. Now bounce the user over to like a confirmation page or whatever it is. You can tell them like, oh, you've successfully performed the action page. Then if they refresh the page they're actually looking at, it's another GET request. There's no side effect. Everything is safe. So you'll often see that in like tutorials or something for various like backend frameworks where they guide you towards this. When a post request comes in, you do the thing and you send a redirect to the page where they're actually going to a GET request, and that's what the user is really going to see as a result. So again, let's start with that difference. Like GET requests are safe and bookmarkable. Post requests have a side effect and are kind of this like fragile thing. If you reload them, that's a sketchy thing to do. From the point of view of a web browser. From the point of view of an API, there's some other request methods that matter. So this is if there's a computer making, a program, I guess, making the HTTP request as an API, Then there's a few more methods that matter. I'm going to leave those. For now, we're talking about web browsers making requests, not code that you wrote. So we'll carry on. Okay, after that, so again, back here, this is back in the nice simple GET request. I clicked a link or I typed a URL. The browser, the user agent sent the request, blank line, that ended the request, and this is the start of the response from the server. So the response is going to look something like this. It's a pretty similar format. There's one line that's special, there's some headers, and then a blank line. Exact same as the request. So that first line is the status line. The important bit is the status code. 200 OK is, I found the page, here it is. Sounds like a good result. This announcement of what HTTP version is being sent back, and this human readable version of this. It turns out this phrase is absolutely unimportant. 200 is the thing that like the web browser reads or any automated thing is going to read. This is just a human readable version of that. And like, okay, this server spelled it a little differently. It was 2 letters instead of 4. Sure. Either way, I got an OK, and then some HTTP headers. So again, it's field : value. Well, I guess I've given away when I'm recording the lecture. Is that right? Yeah. Anyway, yeah, it came from this web server. It is HTML. So the server can say some stuff about itself. Again, this is the one, it's technically optional, but in effect required. This is, what kind of stuff is it? Here's some bytes. How do you interpret those bytes? You interpret them as a JPEG image, as a PDF document, as an HTML document. So that's a internet media type, MIME type, if you're a little bit old school, with this parameter on it that says what character encoding is being used. And I'll come back to character encodings. Just like in the request, there's this blank line that says that that's the end of the headers. And now we'll move on to the message body. Back in the request, our message body was empty. Here, our message body has, well, HTML in it. So in this case, so because it was a 200 OK response, the rule is, like just the thing it says in the HTTP spec is, for 200, the message body is going to be the stuff. You requested this file. That's the actual contents of the file. Just as a footnote, for some of you, this might look familiar, these headers. It turns out they're exactly the same as an email message. So if you've ever looked at SMTP, Simple Mail Transport Protocol, the format is like eerily similar. There's one line that's special, some headers, and for an email, it's things like from and to and subject, and then a blank line, and then the contents, the actual email for an email message. It turns out they just got borrowed. So this thing from like the 70s that defined email, the format got borrowed into HTTP and kind of lives in your web browser, maybe in a way that you didn't know about. In fact, it's why that thing is called the message body, because in an email, it's a message. There's a bunch of HTTP headers that, again, a lot of developers seem to not know about. I'm going to talk about a few as time goes on, but I kind of like this is a nice intro to, again, some of the tricks that can be done with HTTP headers in the response. That again, obviously a lot of people don't know. People should. They're useful. These are good tricks to be able to make your system do. Have a look. Okay, when I said HTTP and I kind of gave this example, I was talking HTTP 1. So 1.0 and 1.1, that's really what I was just talking about. HTTP 2 is conceptually exactly the same. So everything I said about like requests and responses, and there's a status code, and there's headers, and there's a message body, all of that is equally true for HTTP 1 and 2. The difference is how it's encoded. So encoding content this way, in like just plain text, means that the web server has to take like some concept of a date or some integer, encode it as characters, send the characters, and then at the other end, the client has to take those characters and turn that back into an integer, and that's annoying. Like that's overhead on this conversation. So if you did a more binary encoding of that data, it's faster, less bytes, less work to do at either end, but not human readable. So again, conceptually the same, just kind of more efficient. I'm always fascinated by this, that like HTTP 1.0 was 1996, and you kind of get all the way to here, ignoring the next generation of I forget what it's called. Anyway, the proposed HTTP replacement, or HTTP 3, ignoring that, like conceptually nothing's changed. Between 1996, hey, let's send a few physics papers to each other, web, and Amazon exists, web. Same basic idea. That's some remarkably good engineering. As a developer, you probably don't have to worry too much about this. Again, like whatever API you're calling, like whatever method, function, whatever you're calling that generates an HTTP response as a programmer, like you're generating some HTML, you're doing something that causes a response like this. Well, the function call that you make could be turned into this text, or it could be turned into an HTTP2 more kind of compact response. You probably don't have to change anything to make that happen. You express the thought, it can be expressed in HTTP 1 or 2. Let the tool do that. Okay, let's talk some status codes. So the one you saw in that example was 200 OK. There's a bunch more, and again, they're something that can make your web thing, your web system, I guess, better, like just more seamless, easier to work with from the user's point of view, just cleaner. And if you know them, well, you know to look for them. You know to go and find the function call or the method or the argument in your tool that will actually generate whatever status code. So yeah, this is why I'm talking about these. There is this in Wikipedia, this flowchart of HTTP headers that it just fascinates me. So you start at this black dot up here, and it's this huge, like massive flowchart of how should a server decide, right? So if things are just unavailable, the server decides right away. Oh, send a 503, service unavailable. Great. Okay. Well, what if we pass by all those. If it's a GET request, we go this way. The resource exists. Yeah. Somewhere deep down in this flowchart, I will get to a 200 OK. I don't even know if I can find it. If this is something that helps you, like if this is something that here's but that's a 200 OK off in options. Yeah, I'm not going to scroll around enough to find the 200 OK, I don't think, here. Again, if that helps you, like if you want to kind of look through that as a way to explain what these status codes are, go for it. I think whoever created that is a crazy person, but I'm glad it exists. Okay, so these status codes are broken up. Again, they're all like 3-digit numbers. They're broken up in like hundreds. So the 100 series is informational. And by the way, this document is the HTTP 1.1 standard document that officially defines all these things. It is not a beautiful document, but it is informative. So the 100, again, the informational are, let's see, when would you see these in the wild? I don't know that you would. So, the 100 continue is if the request is so big that the browser user agent can't send it all in one shot, then I think, then you can sort of break the request up into multiple pieces, I think. Switching protocols, it would be something like going from HTTP 1 to 2. If the request was made in a way that's like, if you want to, you can respond with HTTP 2. The server can say that in its response, and I'm going to switch here. But mostly, the 100 series, again, like, you don't need to worry about. Let's put it that way as a developer. The 200 series are success codes, and that's where the 200 OK, enters the picture. And this is great. You've requested a resource, which again is the HTTP word for like a file or whatever. You requested a thing. Here it is. So I got it. The message body contains it. You can deal with it. Presumably interpret it according to like the content type and whatever else is in the headers. You can make a request that is a partial content request. So I can, let's see here. I think that's the syntax. You can make a request that's, I only want these bytes from the resource. So I only want a certain byte range. It's probably not going to be in the hundreds. It's going to be, I want the first couple megabytes or something of this thing that I know is large. So then the server, it can come back. The server can just come back and say 200 OK. I don't know what that range header is. Here's the whole thing. Or if the server does know how to deal with that, it can say, oh, okay, you've asked for just this segment of the file. I'm going to start at that byte and send you the part you asked for. So this is something that like a normal web browser is probably not going to do. I guess if you have a big download in the web browser and it gets, the browser crashes or you quit and then it has to restart, the browser would make a request that is like this and say, well, I got the first million bytes of the file, so I need you to start at byte 1,000,001, send me from there on, and the server could do that. Or if you have some large file that obviously you're downloading legally to download, other downloading tools probably will do this trick too. Is there anything else in the 200 range? So there's a bunch of status codes here that again are meant for like an API to work with. So this is the thing interacting with a server isn't a web browser, it's a program. So I wrote some code, it's making the HTTP request and asking for like this action to be taken on the program's behalf. Then it makes sense to say, yo, you asked me to create a record? Well, I've created it. But in terms of like from a web browser to server conversation, that one's probably not relevant. The same thing here. The 202 accepted is you've asked me to do some really big computation on your behalf or something that's going to take a long time. I've started. And with probably some information about, well, here's how you can check back to see if I'm done and get the true response. Content, yeah, I mean, again, I think, well, partial content I talked about. I think that's probably all in the 200 series that I really need to say anything about. The 300 series, I've always thought redirection was the wrong name for this. It includes the redirects. It also includes a bunch of other stuff. It's roughly speaking like, well, I'm not going to send you back. Like, so from the server's point of view, this is, I'm not going to give you the thing that you asked for, but we can deal with this. We don't have to let the user know that anything bad happened. It's between you and me. Here's how we'll deal with the situation. So it can be something like not modified. So I can make a request. I wonder if I can do this. So this is the way for a web browser to say, well, I have this in a cache. Like in my browser cache, I have a version of this page. and I got it at this time. If you have a newer version, send it. But if not, I'm happy with my cached version. And that's exactly what I just got. So I said, if modified since sometime relatively recently, and the server came back and said, yeah, if you have a version that was that new, that's fine. It hasn't been modified since then on the server side, so just use the one you've got. And no message body, right? So a lot of bytes getting transferred just got saved because we were done at that point and didn't have to transfer that page or image or movie or whatever it was. I'm going to come back to caching. There's much more to be said. And again, developers don't know about it, apparently. So the reason the 300 is kind of under the header redirect is a whole bunch of redirect status codes. So these are things that the server can do. Like the server can come back and say, okay, well, you asked for this URL. I'm going to send you over to this other one instead. And I can get there. I can do one of those. This page is 8. Oh, actually, I guess I can do it. I've been ignoring HTTPS, the encrypted version. But what I can do that will generate redirect is, so I'm going to request this page. So this would be just a straight up, request the front page of the notes from this lecture. So I keep hitting Control S just habitually. And so I think if I do that, so I gotta. I get a 301 move permanently. And the difference here is I made an HTTP request and I'm getting redirected to the HTTPS location. So this is, you've made the unencrypted, you've asked for the unencrypted version. No, I'm going to bounce you over to this URL. You can request the encrypted version, which, well, I can't type the encrypted request by hand, so I'm not going to. And that was a 301 move permanently. So there's different semantics here on those 4 redirects. There's this URL is over there and it will always be over there. It is permanently gone to that spot, or it's temporarily gone to that spot. It might come back later, but for the moment, if you want this URL, take the user over there. Or the URL that you requested is gone, and I don't have exactly what you asked for, but I have something that you can take the user to. It's maybe good enough. So this see other. From the user's point of view, those all look the same. They all look like I typed one URL and I ended up at a different one, because the web browser will automatically bounce them over there. The semantic difference is like if you imagine being a search engine. If Google sees a 301 move permanently, that says something about how it should update its index of web pages. If it's a temporary redirect, that says, well, I'm going to go over there now, but I'm not going to change what I know about the web. I'm not going to update those, the database of all web pages. Or, oh, I should go to this other page. I'm not going to take that as the URL of this content has changed. This is new content that I'll index sort of on its own merits. And I don't know if Google really honors these. Again, so many web developers use them incorrectly. It could be that it's just not worth it for Google or any other search engine to really assume that those semantics hold, but you should do the right thing. There's this obvious question of what are these two temporary why are there two things that are both effectively temporary redirect? And the difference is something that I'm not going to get right off the top of my head. One of them is, in fact, I had that. It was actually hiding on that post redirect get figure. For most of the redirects, if there's a post request and then a redirect, it becomes a get. So this changed methods. The post request after the redirect turned into a get. That's one of these. I think it's the 302 found. The 307 is post would get redirected to another post request. And I can never remember which one's which, but that is the difference between the two. Okay, wait, before I move on to the 400s, are there any other 300s that I want to talk about? No. Yeah, not really. In the 400 series, these are errors, and they're errors where like the user did something wrong. Like, this is not my fault as the server, this is your fault as a client, is basically what's being communicated here. Like, yeah, you've asked for that, but no, we're not going to let you see that for whatever reason. Of course, the server can have whatever semantics it wants on its URLs. This is one where you coming from this IP address, or logged in as this user, or not logged in at all, or whatever it is, we've decided on the server side not to show you this content. 404 not found is the basically typo, right? So this is if I'm on some page and I just request some URL that doesn't exist and never existed, well, yeah, 404 not found. What this response shouldn't be is this content used to exist and now it doesn't anymore. If the content used to exist and is moved somewhere else, it should be a redirect to the new location. If it used to exist and now just doesn't, that content is gone, well, there's a status code for that. This is the informative version, which is, yeah, you know what? We used to have that on the web. We had to take it down. It's gone. This is the users shouldn't see 404s. Again, unless it's their fault. If they typed the URL wrong, yeah, fine. Or they followed a link that somebody else typed wrong, fine. A link that works today should never be a 404 tomorrow. Okay, in the client error category, yeah, you know, the syntax error equivalent. I wonder if I can. How bad does it have to be for this? So that's not a legal HTTP header. You know, there should be like a colon. That would be fine, but that isn't. So if I make that request, I actually don't know here. What do I get? So it was actually happy to ignore that. I'm pretty sure that's illegal, an illegal request. I guess I can always just, there we go. Maybe it is legal. Like, there is some rule about continuing an HTTP header on a new line. Maybe that's taken as a continuation of the host, and it's kind of interpreted like that. Anyway, if it's truly garbage, like that was a request I just sent, okay, 400 bad request. Unauthorized. Okay, so the difference between unauthorized and forbidden. Unauthorized is I want you to show the user that old school pop-up username and password dialog that you never see anymore. And I'm trying to, I can't even think of a page off the top of my head that's going to do it. The login, like the standard login, like if I click log out and log in on some website, that's going to be some kind of redirect. So it's going to be, you've accessed this page, but you have to log in first. The modern world, it's temporary redirect to the login page, and then after they log in, redirect to the page they were looking for. The 401 not authorized is a little like pop-up window style of authorization that nobody uses because you can't actually log out with it, and it's kind of odd to work with. Okay, so forbidden not found. So method not allowed could be like, there's this URL, you made a post request. I don't respond to post requests at this URL. I only do GET requests, so 405 method not allowed. Not acceptable. So this, I mean, I'll talk later about the accept headers. That's why this would be relevant. If a request has come in from a client that says, I need a response that looks like this, and the server can't generate it, it would be that not acceptable. conflict is going to be one for, again, an API style request. I don't think I want it. There are a lot of these. Oh, okay. So here's one that would make sense. So if you're hoping to do that range request and partial content response, and you say I need bytes 1 million to 2 million in a small file that doesn't have 1 million bytes, the server could come back and say, yeah, no, I can't do that. The file isn't that big. Where again, like, you can be quite expressive in an HTTP response. And again, part of the reason I think it's worth spending a few minutes to talk about these is a lot of web developers don't know how much you can express with a response code. Okay, so the 400 series are the client made a mistake. The 500 series is there's a problem and it's the server's fault. So the 500 internal server error, say, which you've probably seen somewhere on some website, this is often, it's often like if the code that was supposed to generate that page through an exception, it will get translated into a 500 internal server error. It's like, this is a bad thing that happened. The client didn't cause it. The server caused it. We don't know how to recover from this exception, so we'll just throw up our hands and say 500 internal server error. The gateway errors are, so this is if you make a request to some web server, and that's just the sort of start of the process, that has to make another request from itself back to some other server that's going to do some work, run some Ruby code or whatever. That is, then that front end server is acting as a gateway. So the user made a request to the gateway made another request to something that's sitting behind it, and that second step failed. That's these gateway errors, which is basically a way to say, there's a problem here. It's not my fault. It's that other server's fault. The gateway was the problem. Service unavailable is something that, again, like depending on the tool, you can turn on. So it could be that, you have some website, web system, whatever it is, and there's an outage. Like, like it has to be down for 5 minutes while something fixes itself. You probably want to avoid that as a developer, but there is this like informative, we're down, don't panic, it's our fault, we'll come back soon. Users never deal with it. Like having used a 503 response to indicate, hey, this is temporarily unavailable, with a message that said this is temporarily unavailable, users still email and say, hey, it's broke. Can you unbreak it? Turns out users don't read so well. Neither do students, though, so don't feel smug. Okay. Again, are there others in the 500 range? Again, like I've looked through these, however, like as many times as I've taught this course, approximately, I've looked through these. I totally forgot there's this not implemented. Just like the HTML tags and the CSS properties. It's hard to keep them all in your head. Okay, so service unavailable, gateway timeout. Okay, HTTP version not supported again. So you make an HTTP 2 request to a server that doesn't speak it, it could come back with that kind of response. Like I said, there's nothing, I'm not interested in these on their own. Like if there was a test in this course, a test question would not be fill in the blank 404 and then you have to say not modified. I don't care about that. What I care about is if you're designing a web system, you're writing some code in Ruby on Rails or Django or Express.js or whatever on the back end, you should be producing the right code to convey the right message to the client. And knowing that they exist is the first step. In Ruby on Rails or whatever, there is some way to generate a 410 gone. I don't know what it is off the top of my head, but if that's the message you need to get across to the user, you should know to go and look for it in the reference manual or whatever. Again, first you have to know that gone is a concept. Okay, and again, by the way, I was looking at the reference for HTTP 1.1, HTTP 2 exact same concepts that again are transmitted differently over the wire, and in the new generations tools, they seem to not be changing any of that as far as I can tell. It's just, can we express the exact same semantics and get it to the user faster, or get it to the browser faster? Okay. I guess I've been talking about web servers. I haven't really, defined the concept, but it's client in a client server communication. Usually when you think about web pages, the browser is the client, and then the server is the other side of things. It's this thing called ggbaker.ca or www.sfu.ca. The client or browser or user agent makes a request. The server's job is to respond to the request. And again, HTTP is the thing that is spoken. Web server technology, I mean, there's a lot to be said here. There's a lot of options. In terms of like things that are facing the outside, where a user can connect to them, these are probably the most common choices. Apache was the web server for a long time. Apache will do everything. Like everything a web server can do, every like way to, on that flow chart of all the responses, Apache can be configured to do it. It's very, very flexible. And that is, of course, both good and bad. So this, the Netcraft survey is the sort of place where these things are, like they do a survey of like, here's every web server we can find and how it announces itself. Because again, back here when we were making requests and getting responses, the server announces itself as part of the response. And most web servers do this. It's not required, but it's in practice there. So the survey is basically, we contacted every web server we could think of or find or get, and this is the server software it's running. And the this blue line that's sort of above all here for most of time, from like the late 1990s until recently, it was Apache. Again, it was the dominant web server for ages. In the recent times, like there's this spike of Microsoft-based web servers. I feel like that is probably like the personal IIS, like running on people's Windows computer on a cable modem. Like a lot of those numbers are going to be that, like not web server as I think of it, but hey, it's a computer that responds to HTTP requests, so it's a web server and it gets counted. And then this thing that I'm frankly surprised it took as long as it did, you can see Nginx starting to creep into the lead over about the last year or so. And again, that's what I sort of thought the world should look like. Like I said, Apache is very flexible and does everything. It doesn't necessarily do it super fast. Nginx is designed with a little bit more speed in mind, and it's certainly my default choice. Like if I need a web server to sit, again, user-facing, it's Nginx. And I say user-facing because there's this other category. Well, like I said, there's this concept of a gateway. The user makes a request to a server. The server kind of forwards it to somebody sitting behind an application server. So the application server could be the thing that's actually running your like Ruby on Rails code or whatever. Technically, those are generally implemented as web servers. I don't think of that. If you say, what's a good web server? I would never say, oh, the application server that runs Ruby on Rails code. I would say Nginx or Apache, but they're doing the same job, so they should be in this category. So some of you will have taken like Compute 371 or 471, and there will be a bunch of like server and client conversations in your head. If not, it's fine. The conversation of like an SSH between an SSH client and server is like in some ways simpler and in some ways much more complicated. It's simpler in HTTP in that there's this very nice, easy to understand protocol that is easy to debug and see. And actually, now that I say this, what I haven't done here is brought up the developer tools and pointed out in the network tab. Hopefully I can keep this on screen with a reasonable font size. so I can see here's all the requests that got made. It was just the 404, and then my browser also requested the icon to go up here in the tab. You can diagnose these things in the browser. So this is the request that the web browser made had these headers in it, and then we got a response back with these headers. In particular, so it kind of reformats it. It puts the status code up here. It would have been kind of right above these response headers in the request or in the response. But it was a GET request. It came back as a 404 not found. It's HTTP2 on this server. If I go to something that really did exist, it came back as a 200 OK. This is the actual content that got sent back. I don't know what else. What else is interesting here, and is it any different? I guess from the example I showed. Not really. Again, there's a host header in the request. The accept headers I'll come back to in the response. Again, a few more bits of information about the content, but not too much. And if I have a look, so again, this is HTML kind of content. If I have a look at, say, that one, this was an SVG image sort of content that came back. So the browser interprets it and displays it in the appropriate way. But again, so all that is there to kind of inspect. You can do it with this sort of by hand method like I've been doing. It's a good, like, I like it as a demo to sort of see, look, you can really just type an HTTP request. In practice, I would be much more likely to do something like this. So curl, well, curl by itself just fetches the content. So that's the HTML that was too long to see on the screen. -I says also show me the sort of start of the response. So show me the headers. So it's HTTP2 that's been reformatted to be human readable, but the response came back with a 200 OK, although that reason phrase gets dropped in HTTP2 because it's not actually for computers, it's for people. And then these headers came back. And if you want just the headers, -I is just show me the sort of the start, don't show me the message body. But yeah, like if you need to diagnose, like, hey, what the hell's happening when I make this request? These tools are definitely the way to go. Or again, the developer tools here, if you're in the browser. Again, I like this. I don't know what to show here. Again, you can kind of quickly diagnose like what's going on. Why did things go wrong? Anyway, so the HTTP is, again, simpler in the kind of the like, again, I gave almost a complete reference manual to the protocol there. It's more complicated in that the server has a lot more choices to make. Different things on a web server might come from different spots. Some of them might be generated on the fly. Some of them might be files on a disk. Some of them might be forwarded to some other web server. You wait for the response there and you forward the response back to the user. That complexity comes with complexity in the configuration. So like I said, there's a couple things that can be done here. The thing that, like, I think most users start with, like, I think at least on the development side, is static content, and it's what you've been doing in exercise 1 and 2. I guess depending where you are on those. And so static content is just a file on a disk. So, and it's what I've been doing here, right? Like, as I've created this position.html, I didn't upload it to a web server, but I mean, the intention would be I would take that file, I would move it to a web server. It would be just a file on a disk on the web server. When a request came in, all the server has to do is pick it off the disk and send it, 200 OK, and there you go. The other option there is dynamic content, which is when the request comes in on the web server, basically a program runs. So for content like this, there's nothing, sorry, there's nothing private on this page. This content got generated by some program, right? There's some program that looked in a database and figured out the course title and who the instructors and TAs were, and that there's something called exercise 1 in the course. That's dynamic content. And if I go back to that page in 10 seconds and reload it, I might get something different. It depends what that program does every time the request comes in. And I guess I don't necessarily know that, right? Like if I look at this page, I don't know for sure that it's static or dynamic content. It could be that some system creates an HTML file, throws it on a disk, and that got responded to as static content. It seems unlikely. But even something like the lecture slides, they are static content because I'm in control here. I know that I uploaded some files to a server, and there's like an index.html file, and that's what this screen is, and that there's somewhere in http.html file, that's what this page is all about. I know there's a static. As a user, you really have no way to distinguish. This could have been dynamically generated. You really have no way to know. So the server has to be configured for that. There's something in courses that says this URL is dynamic. It's generated by some specific piece of code that knows how to build this page. But something like, probably this JavaScript file that was referenced in the page, probably this is a piece of static content. I mean, I guess I can make that assumption from the word static in the URL. It's a pretty big hint from the user side, but still no rule. So how does Courses know that this URL comes from a file on the disk and that other URL comes from a certain piece of code? Well, the server, like whatever web server is there that's responding to requests, somehow knows how to chop those URLs up and say, okay, requests that look like this, I'll deal with this way. Requests that look like this, I'll deal with this other way. It's not always easy. Like, again, there's a lot of options there about how to handle different kinds of content and different URLs, and every web server has its own way to be configured. Everything that you're going to do, again, like in the backend, like the Ruby on Rails or the Node.js or the Django or the PHP, like whatever you're writing as a programmer, there's that like all pairs of things problem of the way you can configure PHP code to work in Nginx and the way you configure Ruby on Rails code to work in Apache could be completely different. And the way you configure PHP to work in Apache versus Nginx could be completely different. And it's very easy to get like the wrong tutorial that's pointing you in the wrong direction. What I'm saying is when it comes like project time, don't leave this configuration of your deployment. This is not a last minute problem. Start on that early. Make sure you know how to get your code running in the proper way. And the exercises will, the weekly exercises will kind of guide you through that. Keep in mind, as a developer, I think it's very easy as a developer, like creating a page like this, to say, okay, well, I am writing and I'm doing some database requests and I'm building some data structures and I'm taking an HTML template and I'm going to build the HTML and respond. That I am, as a developer, I'm thinking about the dynamic content. But if you look at the like the network activity here, this content was dynamic. Like one request here was dynamic. All of these other ones I suspect are static. So, okay, 5 kilobytes were generated dynamically, or 36 kilobytes. So that was compressed, I guess. All these other ones just were read off a disk. And I think quite often developers, because they're thinking about the dynamic code, that's what they're writing, they tend to like, okay, look, I can get rid of one database query and I can make my content faster. And then they forget, okay, one database query shaves off a couple of milliseconds or whatever. the user is downloading all of these images and all of this JavaScript, your page is not slow because you had the one extra database query. Your page is slow because of all the other stuff. And that's easy to forget, and it's easy to do wrong in the modern world, especially of web development. Okay, I think that's a good, I'm going to stop there. I think that's about, again, like I've said before, I'm trying to keep my pace where it is, and I think this is the kind of range where I usually stop the second week of lecture. I don't want to keep talking just because there's nobody asking me questions to slow me down. So I'm going to stop there. Hopefully this is going okay. Things to do are really, the thing to do is form groups. Like, get your group settled out for the technology evaluation and the project, and then start figuring out the kind of things you want to do for the technology evaluation, like what technologies you want to choose. Other than that, and I'll send email about those kinds of things. Otherwise, I'll see you next week. Bye.